Hi everyone, in this video we will talk about the frame of reference and we will see example how we can use this frame of reference with a matrix and this frame of reference is a very important concept for the 3D. So I will start by creating a geometry node and I will delete this file node and I will delete this file node and I will create 3-line node. The first line with the same direction of the x-axis. Copy and paste this line 2 times, one for the y-axis and one for the z-axis. So the line 2 have the same direction of the y-axis and line 3 same direction of the z-axis. And it is very important to keep the length of these 3 lines. It is very important to keep the length for these 3 lines equal to 1. Right now I will create a merge node and connect these 3 lines to this merge node, and I will create fuse node. So this is the frame of reference. Frame of reference. So what about this frame of reference? You can see, after this merge node I must create fuse node, and after the fuse node we have this node, frame of reference. So right now you can see that we have 4 points. Point 0 at the origin, at the location 0, 0, 0. Point 1 with the same direction of the x-axis, and point 2 same direction for the y-axis, and point 3 the same direction for the z-axis. So right now if I want to rotate this frame of reference geometry, I will use the matrix for rotating this frame of reference geometry, and I will use the make transform node. So it's the same node like the transform sub node, just it is give me a matrix so I can store the rotation data for the rotation. So I will multiply the position by this matrix from the make transform node, and right now I will rotate this frame of reference by random value. So I will set the value here to -33, and the value here random value -55, and different value here for the z-axis 43. So right now we have rotated frame of reference. So what I will do also, I will keep this rotation matrix and store this rotation data as a rotation matrix. So I will create bind export, but from this matrix here, from this node, we have 4x4 matrix, so I want 3x3. From the convert node here, we can see there are matrix 4 to matrix 3. So connect this matrix 4 here, and the result is rotation matrix 3x3. So I will rename this new attribute to the rotation matrix, and let us take a look to this our rotation matrix in the geometry spreadsheet. So you can see we have 9 components for this rotation matrix from 0 to 8, and as you can see here we have rot matrix 9 float. So for the first 3 component, let us take a look. The rot matrix 0 and 1 and 2. What is the value here? It is 0.41. I will just read the first 2 numbers after the point, and 0.39 and 0.81. And let us take a look to the position coordinate for the point number 1 in our frame of reference. So the bx 0.41, and here you can see 0.41, and you can see that all the number here equal to the first component. If even if we take the 5 number after the point. It is completely the same number here. And for the point 1 also, the second component, the by for the point number 1, 0.38, 0.39 and 0.39, the second component for the matrix. And the third component, sorry, the third position coordinate, the pz, 0.81, and here the same thing, 0.81. So the first three components of the rotation matrix equal completely to the position coordinate for the point number 1 of the rotation matrix. Now the next three components, 3 and 4 and 5, minus 0.24, 0.91, minus 0.31. Let us see. Minus 0.24, 0.91, minus 0.31. So it is completely also the same thing. You can see 31 and 31 here. So in other words, the next three components for the rotation matrix completely equal to the position coordinate for the point number 2. And the last three components, let us take a look. Minus 0.87, minus 0.07, 0.48, minus 0.87, minus 0.07, and 0.48. So the last three components, it is also completely equal to the coordinate position for the point number 3. The point number 3 was with the same direction of the z-axis, and 2 the same direction with the y-axis, and 1 the same direction with the x-axis. So in other words, I can create a rotation matrix using just, or I can save, or I can know what is the rotation matrix for this frame of reference using just the position for these points, point number 1 and 2 and 3. And using this position, I can know what is the rotation matrix, and I can invert this rotation matrix and revert this frame of reference to the initial location and initial orientation. So I will show you, or we will see example in Houdini how we can use this frame of reference. I will not show you how we can use the rotation matrix with this frame of reference, and we will see how we can use the matrix with the frame of reference in the next example. In this example, I will show you how we can use the frame of reference to restore the initial position and initial orientation for the geometry before any animation. What we have here, we have this curve. I will use it as a path for creating animation for this geometry. So I will set the path object here in this geometry to the path, and I will set animation here, simple animation, and this is the animation that we have, simple and easy animation. So right now I will hide all these nodes, and I will create another geometry node, and I will delete this file node, and I will use the object merge node. I want to import this geometry. So you can imagine that I don't have this object merge node. I have just a file node, and I already saved all the geometry, all the animation, or the animated geometry for each frame to the hard disk. And right now we are using the file node, and we imported this animation. So right now I will use the object merge. So I want to import this animation. I don't have any geometry, I don't have any path, I have just the saved geometry on the hard disk. So you can imagine that this is file node. So this is the animated geometry. So as you can see, we have just animated geometry and there are no frame of reference with this geometry. Right now, if I want to modify this geometry, so after the animation, I want to modify this geometry. For example, let me try to modify this part of the geometry. So I will use all these points. I'll select all these points, and from the deformer tab here, I will select deform, and I'll start deform this part of the geometry. Okay, let us see what we have for this geometry if we will play the animation. I will create an all node here. Sorry, not merge node, an all node. And let's see what we have here. So you can see right now we have the deformed geometry here. It is different from the first frame. You can see right now we have this nice and this deformation, but when we have animation, everything it is changed, as you can see. So how we can solve this problem and how we can use the frame of reference to solve this problem and to see how we can use the frame of reference for restoring the orientation and the position for the animated geometry. We must be sure that before we save any animation to the hard disk, we must have a frame of reference assigned to each geometry. So this is the frame of reference that we already created it. As you can see, it is 4 points, 0 and point number 1, 2, 3 for the X and Y and Z axis. So all what we must do before we save any animation to the hard disk or before creating any animation is merge this frame of reference together with the geometry that we want to animate. So we have right now this is the geometry and we have 4 points in the frame reference. So we have this frame reference group, and right now we have here the animated geometry and we have the frame of reference together with this animated geometry, as you can see. Now how we can use it, and one other thing, when we use or when we attach or when we merge the frame of reference together with the geometry, it is more easy to make or to connect the frame of reference firstly to this merge node. And in this case, you will see that the first 4 points, it is the frame of reference points. This is the point number 0 and 1 and 2 and 3. As you can see, point number 0, it is at the location 0, 0, 0. Point number 1, 1 on the X. Point number 2, 1 on the Y. Point number 3, 1 on the Z. So it is more easy to work with if we would connect the frame of reference to the first point, to the merged node firstly. So how we can use the frame of reference to modify the geometry without have a different shape through the animation, or to save the modified geometry have the same look through all the animation. So I will show you. First thing, I will create a transform node, and I will use this transform node to keep the geometry at the position 0, 0, 0. So we know that we can use the position coordinate for the point number 0 of the frame of reference. So I will use the point expression, and from the animated geometry, and I want the point number 0, I want the B attribute, the facet component, and of course we must use a negative value. So this is for the X, and for the Y I want the facet component, facet component, and for the Z the second component. And right now you can see we have the geometry or the animated geometry all the time at the location 0, 0, 0, but the orientation, it is still as for the animation. So we have the location set to the 0, 0, 0, but we still have a different orientation. To keep the orientation for the geometry, or to keep the initial orientation for the geometry, what we can do, I will create a point VOB, and I will use the position for the points 1 and the point 2 and the point 3 to create a matrix and invert this matrix. So I will create import point attribute, and I will create a constant for the point number. I will use here the point number 1, and I want here from the first input I want the position, and I will create vector to float node, connect the result here. So this is the coordinate position for the point number 1 of the frame of reference. I need also the coordinate position for the point number 2 and the point number 3. So paste and copy 2 times. And here the point number 2, and here the point number 3. So right now from the matrix tab here we can use float to matrix 3. So we know that the first 3 component of the matrix, it is equal to the position coordinate for the point number 1. So I'll connect this 3 float position to the first 3 component of the rotation matrix, and the next 3 component of the rotation matrix equal to the position coordinate for the point number 2 of the frame of reference. So connect this 3 component, this 3 position to the next 3 component, and the last 3 component of the rotation matrix equal to the position coordinate for the point number 3 of the rotation matrix, and connect all these 3 positions to the last 3 component of the matrix. And as you can see here the point number is 3, and here the point number is 2, and here the point number is 1. So what we have here, we have the rotation matrix for this geometry right now. If we want to undo the rotation, all what we must do is creating from the matrix tab here, you can see there are the invert node. So invert the matrix, or the invert of this matrix, that is mean the matrix that it will undo all the rotation that already created by this matrix. So multiply, so from math here create a multiply node and multiply the position for each point by the inverted matrix. It will give me the initial orientation. It will give me a geometry without any orientation. As you can see, there are just the reflection of the light through the animation, but we have just a static object. There are no animation, there are no motion completely. So we save the animation sorry, we restore the position and restore the initial orientation. And right now we can modify the geometry, but here we modify the geometry without using the frame of reference. So all what we must do is creating a delete node, and here delete frame reference, and delete the frame reference pointers, and we have the modified geometry. Now if I want to restore the animation, it is the same process. I will just copy this point VOB, and here I will restore the orientation. So this is the geometry, the modified geometry that I want to restore the orientation. Restore the orientation, it is before we reset the orientation. Here restore the initial orientation. And here restore animated geo orientation. Sorry, orientation. So restore the animated orientation. It is the same process, just without invert. But here I must take the position coordinate for the point number 1 and the point number 2 and the point number 3. I must take the position coordinate for these 3 points before this node, before restore the initial orientation. So connect this transform node here to the second input, and in this node here, import the point attribute. I will set this parameter here, the input, to the second input for all these 3 nodes, from the second input and from the second input. And we already deleted the invert node, and let's see the result. Restore the orientation, and you can see we have the old orientation for the animate geometry. Okay, and if we want to restore the position, copy this transform node and connect here after restore the orientation, just without minus, and let's see. So nice, and you can see we don't have any problem with the modified geometry. Completely, there are no problems with the modified geometry because we created the modify when the geometry have the initial rotation and initial position, and restore the orientation and the position for the modified geometry again. So this is very useful, and when creating animation for the vehicles, it is very useful to use the frame of reference. I will rename this to imported animation. So we know how to restore the animation using the frame of reference. As I told you, it is very useful way for create a frame of reference geometry attach it to each geometry, and save this frame of reference in groups. And how to restore the initial position and initial orientation. This is how creating a transform node to restore the position first thing, and then creating this point loop with this thing. Use the point number 1 position, point number 2, and point number 3, and create a matrix. Invert this matrix and multiply this matrix by the position coordinate to restore the initial orientation. Create the modify or attach another animation to this geometry again with the initial position and initial orientation, and apply the orientation again and apply the position. And this is, we can create here, we can create an all node. So out here and render. So thank you for watching, and see you in the next video.